Okay, so this week is your guys' first introduction to programming in Unity, and for a lot of you, this is going to be the biggest leap you take in game design, and it might take a while to click. For me, it took about 3 months before I actually felt somewhat comfortable in what I was doing when programming in Unity. And before we start talking about the assignment, yes.
Does having programming background
Help, yes, exponentially. Specifically in C-based languages. Now, before we start talking about the assignment in programming in Unity, we need to talk about what a programming language actually is. And I'm going to sum it up in a very, well, not stupid, but quite a simple way, because you guys don't need to know super in-depth. But in simple terms, the computer uses what's called binary to do different things. That's a collection of ones and zeros in different patterns. Brett, hello, welcome.
Exist.
he does in fact exist. And so, what was I saying? Yes, the computer uses a collection of ones and zeros to do different things. So, in simplest of terms, I don't know if you guys have ever seen those circuit boards before, where it's like if this, with different gates and stuff, like if this is a 1, if this is a 0, then this light over here will light up. That's a very simple way of explaining how computers work and how they communicate information. It's ones and zeros and things on and off. Now, that sucks for people to work with. You don't want to spend 24 hours typing in hundreds, if not thousands, of ones and zeros just to do one thing. So we use what are called programming languages or visual scripting. Not visual scripting, that's a different thing. I'm getting that mixed up with Visual Studio. We use programming languages. Now, you're going to hear the term compiler probably a lot, and what a compiler is it essentially converts your programming language into binary for the computer to read. The programming language is not for the computer. The programming language is for you to type out what you want the computer to do, and then the compiler converts that to ones and zeros for the computer to actually execute. So, whatever programming language you're using, eventually it's going to be all ones and zeros. Now, a lot of times when you're doing scripting, hello, Mr. Simpson.
Hey, bud.
A lot of times when you're scripting, you will need to download first off, a visual scripting software, which when I say visual scripting, I mean something like Visual Studio or Visual Studio Code to be able to see the code that you're typing in, right? You would also need to download a compiler to then run your code through to execute it. Now, luckily with Unity, we actually don't have to worry about the compiler because Unity is its own compiler. It does that for you. It's a game engine. You're working with its API to create something. So you don't have to worry about downloading a compiler. You already have Unity. What you do need to worry about is you still will need a code editor. So you can use Visual Studio Community or Visual Studio Code. I personally prefer Visual Studio Code, which is what I use. The difference, I guess I would say, Visual Studio Community is probably better if you're starting out because it has more auto-correct features and checks that you can do. But it kind of is a pain in the ass sometimes with making you sign in. So I just prefer Visual Studio Code, and I've used it more. Now, in the Module 5 here, instructor notes here, you'll get a link to Visual Studio Code. Now, what's important is after you download that, being able to set it up with Unity, and so I'm going to show you how to do that real quick. It's not too complicated, and I actually haven't been to that part of Unity's UI, API, whatever you want to call it, in a second, so I have a general idea of where it is. We're going to open our project that finally finished importing. So we're going to go to Add, we're going to go to Desktop, and we're going to click on this. Well, you're not valid. How about that? Oh, I see what's happening. It's in a file within a file. Okay, yeah, that would cause a problem. Let's try this again. There we go. Okay. So we're going to go ahead and open this up. So yeah, Unity uses the programming language C# and then converts that to binary to use. So C# is a pretty widely used language along with C++. Those two are very common for game design. And so C# is what Unity uses, and that's what you're going to be learning for Unity. Now, one thing I want to stress, this is very important, is that C# with Unity, its syntax, or another word for, like, I guess you could say like spelling, if it was a written language, is a little bit different than C# by itself. Because you're using it with Unity, there are a few niche things or syntax and functions that Unity has that you'll be using. Now, don't worry about what's in this scene yet. We're going to talk about that in a bit. So, if you've downloaded Visual Studio Code or Visual Studio Community, you need to tell Unity, hey, this is the code editor that I am using to edit code in. And if you don't, it's going to get mad at you if you try to open up a script. So, I believe, and we're going to see if it's in project settings. It might not be in project settings, but I thought it was. Scripting is not what I want. I know what's in here somewhere. I always forget where this is, and then I figure it out again, and I'm like, ah, yes, and then I forget again. It's something that's honestly not too hard to find. It's just one of those. It won't let me see the full drop down of stuff. I think it's in preferences, maybe. Let's see here. External tools. Yes. External script editor. So, this is where you will specify what you're using. So, right now, it says open by file extension right here, and I've actually already selected my Visual Studio Code. So, what this is going to look like for you, there'll probably be nothing selected here unless it magically automatically did it for you, which that's possible, I suppose. So what you'll do is you'll click this right here, and keep in mind, this is actually, I should show you how to get here. Hold on. What you're going to do is go to Edit, and then down here, can I click? Ah, here we go. There's a Preferences option here. I'm used to it showing the entire thing, but this is zoomed in. You're going to click your Preferences, and in External Tools, that is where you're going to change the code editor. So, you're going to click Open by File Extension, and click Browse. Now, I think, yeah, this uses, it should, wherever you download Visual Studio Code to, that's where you're going to want to go. Now, it looks like we're using, I think this is Visual Studio Community on this computer specifically, which is fine. And this didn't exactly take me to where I wanted. I want to get to, I think it would be, don't be mean to me. Where do you put it automatically? I don't think it's... See, sometimes it puts it in different places, and I really don't appreciate when it does that. I don't think it would be... Actually, that would probably be why I'm not seeing it. Hold on. Nope. Why are you being mean to me? Well, this is just... This is not very nice, is it? It should tell you when you download it where it put it. I don't know where it put it on my computer right now. But when you download this, which I'm just going to do, I'm just going to download Visual Studio Code. This actually works. If Visual Studio Community is set up here, then I can just show you how to set it up with this. So here we go. So first off, when you download it, you'll have this setup here, which you have for most things. Let me minimize this stuff real quick. Just make sure you click Accept Agreement. And this is the agreement here if you want to read it. Now, this is where it shows you where it's going to save it. You can change where it's going to save it. So, we're going to look at this, and I'm actually just going to copy this so that way I don't lose it. It's going to save it on in App Data, Local Programs, Microsoft VS Code. Cool. Lovely. Visual Studio Code, next. And if you want, you can create a desktop icon. I'm just going to go ahead and do that, because why not? And then you're going to click Install, and you're going to wait for it to install. So again, this is very important. Make sure you remember where that's saving it to, or you can change the location yourself. Either way is fine. Finish. So now we have this, excuse me, no, it'll apparently open it right up. I don't, well, actually, probably want to choose your theme. I'm going to do dark modern theme. And that should actually just save it. I'm going to X out of that. You don't need to open Visual Studio Code up at all, actually, for this. So we're going to go back into our project. Now we're going to open file by extension, go to browse, and this time I'm actually just going to copy and paste this into there. Let's go back. No, don't be mean to me. Hold on, let me bring this over here so I can see more of it. Here we go. So we can see here, if we go into Programs, Microsoft VS Code, yes, that should be what we have to click on. So if we click here and click Open, it won't work. Is it the bin? God damn it, it's been so long since I've done this. I apologize. Are you being mean? Why are you being mean to me? Do I just click on this one? Come on. This one? Haha! So, that's what you're going to click. Okay, hold on. Let me do that again. So, when you go into here, when you finally find the location, it's going to be this code here with the beautiful blue symbol. Don't worry about anything else. Just click on this. I couldn't remember how you do it. It had been so long. So, that is how you will link Visual Studio Code or Visual Studio Community to this. It could possibly be a bit different with Community. I think it's actually easier with Visual Studio Community, but I guess it's better I showed you the hard version, the hard way, with code. Again, either one you want to do works. I just prefer Visual Studio Code, and if you, but if you want to use Community and are having trouble getting it set up, just let me know. It should be a very similar process to this. So, once you have that set up, we can actually get started. Now, before we actually talk about the assignment, I'm first going to create just a little just example script to just show you the basics here. And in the instructor notes here, there's one video here. There's some additional videos you can watch if you want, but this video here I'm requiring because it is extremely useful, which is the Learn C# with these 9 lines of code in Unity. I really want you guys to watch this. It's like 25 minutes, I think, so it's a bit longer, but it's very much worth it. And I remember this helped me a lot when I first started learning. This is something I found myself, so I really would recommend that. Now, for the actual assignment, don't worry a ton about this right now. This is basically what I'm going to give you this script, and I'm going to be explaining this script. The script you're going to actually be typing up yourself is going to be extremely simple, but you're also going to be making this work. Now, let's go ahead, and when you're creating a new script, there's a few ways you can do this. I would prefer you go into your assets and create it in here. So I'm going to go into my scripts folder. I'm actually going to create a new folder first. I'm going to call this tests, or I'll just do examples. So you're going to right-click, create, and then C# script is at the very top. And now, this is very important. This will cause issues. Do not rename your file after you name your C# file after you've already named it once, or it will get very, very mad at you. So we're going to name this example scripts 1. That's horrible naming, but whatever. Now, once we've named this, ooh, got upset with me. Hold on. It's reloading the domain. Give it just a sec. Come on. There we go. So, when we open this up, Jesus, it opens it up in Visual Studio Code. Yes, I trust the authors. Leave me alone. So, every single script you make in Unity is going to look exactly like this at the start. This is exactly what you're going to get every time. Now, over here, you can actually see our assets, scenes, materials, all this stuff over here. You don't really need to worry about that. Now, I'm going to go through what you're seeing here, line by line, and explain what each thing is. It's okay if you don't remember it. And by the way, it's also okay as you're learning C# and Unity. If you have to look things up, that's fine. That's like half of what programming is anyway, is research. So, first off here, we have these usings here. What does this mean? Well, these are basically getting references and packages that we're using to actually code. So, for instance, it's using systems.collections, which is just a collections of functions and data that we need. Systems collections.generic is basically the same thing, and then also Unity Engine. Do not change these. We will, at some points later in this class, be adding usings that we need specifically so we can use different types of functions and things in our scripts. But right now, don't touch these. This is basically references to things that we need to be able to do what we need to do. So that's what that is. Now, this public class here, we're not going to talk about classes in this lecture, but all you need to know is that everything that is happening in this script needs to be within this public class. Now, this is your script name here that you have, and then we're not going to worry about this mono behavior either. Just it's there. Don't worry about it. Inside these brackets here, this is where everything needs to be put. Do not put anything else outside these brackets. This acts as like a container for your code. Now, if we were making other classes, we would put those outside of this, but we're not going to talk about that either. So let's actually worry about what's in your class, in your script. So first off, what Unity has, and this is unique to Unity, when you create a normal C# file, this or any other file, this will not have it. This void start and void update is unique to Unity. So it says start is called before the first frame update. What that means is that anything you put in this start function, so within these start brackets here, will be called once when your game loads. So one time. So this could be things like spawning the player in or other things like that you would just do on start or assigning values. Void update. Update is called once per frame. Now, what this means, this is a little deceiving. So what the update does in Unity is this will be called 60 times a second. 60 times, that's a lot of times a second. So be careful what you put in here. So for instance, just to show you something, I'm going to put a debug.log, which this is also unique to Unity. In actual C#, it would be console.writeLine, but we're going to do debug.log, and this is basically a way for us to output text in the log terminal. The player will not see debug.logs. You will see debug.logs. The player will not see this. So in here, we are going to put just test. Now, it's important, and get used to this, in C# that you end things with a semicolon. That's basically like a period. This tells Unity, this tells it that, hey, this line of code has ended. We're done here. If you don't put this here, it's going to get mad at you and assume you're still going with whatever you're trying to tell it to do here. So make sure you put a semicolon. So what this is going to do is it's going to output the word test in our log terminal 60 times a second. So right now this won't do anything because this script is not anywhere in our scene. We can put this anywhere in our scene that we want. We can't just drag it onto it. We're going to create an empty game object and just call this test. Doesn't matter where it is. And we're going to drag the script onto our game object test, our empty game object, right? So now this script exists somewhere in our scene. So we're going to go to our console, which is where this is going to output this. So if we click play, you'll see we're getting a lot of tests, like a lot. This is how many, like a lot. So let me pause this. You can see it's been outputting a crap ton of text. This is the update function is a very powerful tool, but be careful with it because it's also how you can make your game lag out and crash. So that is what that does. Now, this void here, it's not important. Just know you will type void before creating these functions if you need to recreate them. Basically what this is sometimes what you can do, and it's kind of hard to explain if you don't have prior knowledge, but you can make functions, because that's what these are. These are functions of certain types. So of type integer and of type Boolean. So but that doesn't really matter right now. When you're not doing that, it's just you type void because that's what it is. It's not of any specific type. So don't worry about that right now. You're not going to understand it yet. It's okay. Now, in this first example script here, and this is what I am going to actually have you guys type up, and this is not going to be a script I give you. It's going to be one that you see, like, there'll be a screenshot image of it, so don't worry. But it is something I want you to type out and get working yourself, and the reason I want you typing code is so that you get used to it. The other script is one I'm just giving you, and that I'm going to be going over how it works and why it works. Now, the first thing we're going to do, though, before I type up the script that you guys are going to type, is we're going to go over some basic things here. So the first thing we're going to go over is variables, and these are very important. And the best way to explain variables is they're essentially containers that hold a specific type of information. Variables are how you're going to store data within your code. So there are a lot of different types of variables. We're going to be going over just a few that are very common. So The first one that we're going to go over is an integer value. So, to create an integer variable, or any variable, first you're going to declare what type of variable it is. So, it is an integer variable, so we're going to type int. Cool. The next thing that you're going to do is type out the name of the variable. So we're just going to call this myInt. And then lastly, there's two things you can do here. One, you can close it off with a semicolon. Now, what this means here is that you've created this variable, but it doesn't have any value assigned to it, or it's null, which is another word for zero. There's nothing. Now, you can directly assign a variable here, or a value to this variable here, by putting an equal sign and whenever you want it to equal. Now, integers, what's important about these is they are not single digit, they are numbers without any decimals. So this is not an integer variable. This is not okay. It won't accept that, or it'll either cut this down to just a 2, or it won't accept it. It'll either round up or down, or it won't accept it. Can't remember exactly if C# does that or not. I know C++ does. So an integer is a whole number, basically. So 2 would be fine for an integer, 200 would be fine for an integer, 1.5 would not. So that is an integer variable. The next thing we are going to go over is booleans. Now, these are probably the simplest one and also one of the most important types of variables. A boolean is very simple. It is basically a true or false statement, a 1 or a 0. So to specify it's a boolean, we're going to type bool. We're going to name it myBool. Now, once again, we can close this off, or we can also set it equal to something. A boolean can only equal false or true. Booleans are great because you can check if something is, well, true or false. For instance, maybe we had a check to see if this integer was greater than 5. If it was, maybe we'd set this to true and then do something based off of this, right? So that is a boolean. The next thing I'd like to go over is a float. A float is similar to an integer, except it actually takes decimals. So we can name this float, we'll say my float. We're going to set this equal to 6.3512. And there's our lovely float here. Now, I believe, let's see if this gives me an error actually. I don't know if it will right now. No, it's fine. This is a warning. Well, we do have one. What is this? Well, does it play still? If it plays, it's not really a big deal. I'll compile it. Well, I'd like to see the error because that would be cool. Can I? There we go. Yes, good, cool. That's what I thought. I believe, let me just double check this. Yes. So for whatever reason, I'm not sure why, Unity gets really mad at you if you create, hey, any day now. Okay, cool. So right now, these three are warnings. It's saying, hey, you've created this variable, but it's not being used anywhere. You don't really need to worry as much about warnings. Your code will still run. Everything is fine. It's just, usually it's stupid stuff like this. Like, yes, I know I've created these variables and I'm not using them yet. Leave me alone. Now, red ones are bad. You have to get rid of red ones most of the time. So what it was getting mad at is in Unity, when you create a float, you have to put an F after your number. For some reason, I don't know why. I don't know why it can't just tell it's a float by it being a float, but you know, whatever. Same goes for if you're using the values down here. You have to put an F at the end of it if it's a float. I don't know why. It just is the way it is. So these three are the ones we're going to stick to for now, except for one extra one, which is unique to Unity. This is not something that is in other scripting languages outside of Unity. It's not even in C# outside of Unity. This is unique to Unity, but it's very important. So we're going to go over it. Another type of variable is a game object, and which I know that sounds weird. You guys have been learning about game objects, but this is how you will reference them in your scripts. We can create a game object variable that holds, like I said, a variable is a container of data that holds a game object. And then we can reference that specific game object and do things with it in our code. So we're creating a variable of type game object, like we specified here, and we're going to name it my game object. See, it's actually green because it's an object within our scene. It's a bit different. And then we can actually set it equal to a specific type of game object. Not up here, though. This is something you'll want to actually do in your start function. So we have this game object, right? And it's my game object, but it's not really assigned to anything. So there's a couple ways you can assign a game object variable. The first way, and probably the most easy way, is by making it a public variable. And I'm glad we're talking about this because it's important. So in addition to creating the type, the name, and setting its value equal to something, there's another thing you can do in Unity. Right now you'll see on this game object here, on our test game object, we have this example script, but we can't see anything in here, right? It just says script and then shows what script we're using. Now, you can make variables in Unity public. This is something you can do in other programming languages as well outside of Unity. What it means when you make a variable public is that scripts outside of this script and classes outside of this class can actually reference and use these variables. It does that in Unity too, but it also has another use. And that other use is that in the editor, you can actually see and change the value of this directly within the editor, which is extremely useful. So I can change this to 7 here. Now it will still say 5 within the script because that's the default value you've set it to, and if you were to drag this in as a prefab, it would by default make it 5. But since we've made this a public variable, we could also just get rid of this, and now we're actually just changing the number within our scene here. So we can make variables public by putting a public right before them, or we can also make them private. Now, private basically just makes it so no other scripts can reference this. It is only usable within this class here, in this script here, so we won't see this anymore. Now, this leads right into, or you can also not use either of those. So, you can also do this with game objects. We could make this a public game object. Now, what does that mean? Yes?
Why would we do private if the variables already are attached to the void statement?
What do you mean?
Like, why would... So, how I understand it is public, you are allowed to access it from other
Yes.
scripts, other, like, functions.
So why would you make it private at all?
Yeah.
So the main reason for private, and you really won't need to do this much in Unity, is to make your code more, gosh, what's the word? Secure, essentially. It just locks it down a little bit more, because when you don't make it private, there's a couple ways you can reference it outside of it. I forget what they are, but it's not, like, you can't do much with it. It's more of a, what would you call it? More of like a convention that programmers do, especially in Unity. It's not necessarily a super important thing. It's more about protecting your data and keeping it all contained and making sure there's no openings or slippage, if that makes sense. But you don't need to make it private. I mean, this int being just like this would basically have no effect. It would basically do the exact same thing as it would here. Now, that being said, there is one more value type I do want to talk about, type I do want to talk about, which is static, public static. Now, a public static object is a bit different from a public. A public allows you to change this within the editor. A public static allows you to see it in the editor, but you can't change it in the editor. Now, why would you want to do that? I say you can see it and then can't change it. Hello? Why are you being dumb? You should see it here. Okay, we're going to come back to this. I don't know why that's being stupid. First off, let's talk about this game object. Oops, let's not do that. So, we've made this game object public. And like the integer from before, we can see this and change the value with here in the scene. Now, you'll notice here there's no value for me to click here and change, but there's a game object selection here. So we can click this dot here and we can select any game object within our hierarchy, but usually what I do is just drag it in. So we could actually, let's make a cube, let's make a game object that we're going to use for our tests here. And let's go ahead and bring it up here. So here's our cube. Now, in our test script here, we're going to go ahead and drag this cube object into here. So now, my game object, this variable we've created here, is actually equal to this cube right here. Now, this is one way to assign a game object. This is great, but sometimes this won't work, and here's why. It will work in most cases. However, let's say you made a prefab, right? You made a prefab of an enemy and maybe like different enemy types, and then you made an enemy spawner, right? Maybe the enemy spawner needs, or each enemy needs a reference to the player, right? Because a lot of times enemies in Unity, when you create them, need the player's position so they can find the player. So it needs a reference to the player game object. If you made an enemy in your scene, you could do this, right? You could create a reference here. You could call this player position, right? And drag the player game object into there, and then it can track it, and you can track it within your code. The problem is, if we have a prefab of an enemy and we're constantly spawning different enemies in, by default, this is going to be set to, well, nothing when it spawns in. It's not going to have a value, regardless of if we dragged in the player on the original prefab. It doesn't matter. So this will not work in those examples. So sometimes you can't do that. We're going to get rid of this public here. So you have to assign it down here in the start. Now, I'm going to show you one way to assign it. I'm not going to show you a more complicated way yet, because you already have enough information going into your brain with this. And it won't be useful for a while anyway, but I will talk about it. So the first thing you can do is, excuse me, there we go. Okay, so the first thing you can do, you can set my game object equal to this game object, and when you say this dot game object, it means the game object that the script is currently sitting on. This is basically completely useless. Script is accepting it. Well, that's just wrong. Game object. What did I do here? My game object is this dot game object. It's this dot game object. Ha! Got you. Okay, the G it did not want the G capitalized. This is basically useless, and the reason for this is that we're setting my game object equal to the game object that this script is currently on, right? The reason this is stupid is because you can just, when you have a script on a game object, you can just get a reference directly to that game object. So, right, one reason you might want to do this is then, oh, in the update, or maybe in the start here, we're going to destroy, and then we're going to say my game object, right? Which is now equal, and this is basically a way to destroy objects in your scene, destroy game objects. So we've set this variable equal to this game object. Now, this would work, right? If we click play here, it will destroy this object right when it starts up. Okay, well, that was, thanks. Appreciate it. What? Excuse me? Let me just see something here. Do it. Oh, I'm actually dumb. Funny story. Of course it's not destroying it, because it's well, no, it is on the game. What are you doing? Unity, you're being goofy. I don't very much appreciate your goofiness. Oh, wait, because I didn't set it to the cube. What am I doing? I don't know why I'm trying to show you what that was doing. I'm being a goofball. Yes. Okay, it's destroying. If you look here, for some reason my brain had attached it to the cube. It's not assigned to the cube right now. I don't know why my brain thought the cube was still assigned to the game object. Right now, what's assigned to this game object is my game object, which is this game object that the script is on. So if we tell it to destroy it, you'll see the script is on test. Watch right here when I click play. There we go. Test disappears. It's gone forever. Now, the reason this is pointless is because you can also just get rid of this here and just say game object, destroy game object, because when you say game object, so you'll see it still destroys it. When you specify game object in your scripting without specifying anything else, it automatically will just assume you're referencing this object here. So this .game object would work as well, but you can also just put in game object if you want, and it will destroy it. Now, that's not very useful. Assigning this variable to it, this object, is not useful because you can just directly reference it here. I just wanted to show you that for the future. Now, one thing you can do to assign it to another game object within your scene, what you're going to actually do, and I'm not going to type this out because it's a bit longer and again, I don't want too much of this in your head right now because this is more complicated to some extent, is you can actually search your hierarchy for a specific type of game object. So you could either search for a game object tagged a specific thing, which we're going to go over tags in a bit, and then assign that object that's tagged that specific thing to that game object. That sounded weird. Or you could search by name. So maybe we name this cube underscore 001, right? So what we could tell it here, in here, again, it's a bit longer, I'm not going to type it just yet, is you could say, hey, this game object, maybe I will type it, hold on. This game object is equal to, I believe it's gameObject.find or search hierarchy. I think it's a search hierarchy function. I don't 100% remember the function. I might have to actually look it up. Again, you're not going to remember everything. And then you would specify in here cube underscore 001. I do not think this is the syntax for this. Yeah, no, it's going to give me an error. The find is not the correct one. It's like search hierarchy or something like that. But it doesn't matter right now because you guys don't need to do that. But just know that you can do that if you ever are having that problem. So that's another way you can assign that equal to something. So we're going to bring this back to public, though, because we don't need to worry about this in our example here. And we're going to set it equal to our lovely cube here. And so when we click play, this is actually going to get destroyed because in our start, I really don't appreciate destroy. Oh, it's because I'm still destroying the game. I didn't specify my game object. So we're destroying, and then what object are we destroying? My game object, the specific object that we specified here. This has to match this if we want to destroy the game object that's assigned here. So now when we click play, the cube will disappear. Right, Unity? Right? The cube, there we go. The cube disappears. It's beautiful. So that's just one example of something you can do in your start function. You can do a lot of different things with game objects. I'm going to take off my jacket. It's actually hot right now. You can change the position of game objects. You can get collisions and tons of other fun stuff like that. Now, the script that I'm going to have you guys type up is relatively simple, but will require you to use certain things. So, what we are going to do, and what you guys are going to type up, is it's going to be similar to this. There's going to be a difference, though. We're going to take this out of our start function. What we're actually going to do is we're going to get an input. So, Unity, first off, that destroy function there is a specific function built in with Unity. That would not work anywhere else. That is a Unity-specific thing. Now, what we're going to do here, and the reason I'm having you guys do this, like I said, is to get you more comfortable with using certain things, is we are going to actually get the input from the player and then destroy the object if they place or press a certain key. So how do we get the input of the player? Well, first off, anytime you get the input of the player, it will be in the update function. The reason for this is when you're looking for input, you're trying to do it as fast as possible, right? You're constantly checking. Is the player pressing this button? Is it pressing this button? No, still not pressing it. Pressing it over and over and over again, 60 times a second, which is really important. If you put this in the start function, it would only check it once. And so if you didn't press it at right when the game starts, then nothing would happen. So we're going to do it in the update. Now, this is also going to be your introduction into if statements, or what some people call branches. Basically, how your code works is it runs from top to bottom whenever you run this, right? It goes and it's like, yes, this is set to this, and then it does whatever's in the start function, then it does whatever's in here, right? It runs top to bottom. Now, these, you can look at it as it runs top to bottom, and then it does this once, then it goes down to here, and then it goes boom, 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 over and over and over again for infinity. Now, it will also run code below this, so it'll go past it, and then runs this stuff as it's still running this for infinity. This will run forever. The void update will. So in here, we're going to check if the player presses E. E is going to be, actually no, we're gonna do Q because I'm using E for something else for that other script. Anyway, we're gonna check if the player presses Q. If the player presses Q, we're going to destroy a specific object. So we're gonna say if, and this is how you start an if statement. You're gonna go if, and then parentheses, and then we're going to put brackets on the end here. So now, this right here is an if statement. Right now, there's nothing in it. This right here is what you're checking, right? And if this is true, it's going to run the code in here. If it's not true, it's going to just pass the if statement. It's not going to do this, right? So it's only going to do this line of code if this in here is true. So what are we checking is true? We're going to check if Q is pressed. So if, and then the syntax for this, which again, this just comes with practice, you'll memorize it eventually, input dot, that's not a dot, input dot get key down, and then its own parentheses here, and then we're going to specify what key. We want it to be Q in quotations. So let's make sure we don't have any errors, and I didn't forget the syntax. It looks like it's going to be fine. Just give it a sec, and we're good. Okay, and we're actually going to go ahead and debug this. This is basically just how you can test it. You can add what are called breakpoints. I'm not going to show you that just yet. Instead, what you actually are going to use is, well, debug.log. I'm going to show you why you would actually output stuff in the log terminal. Let's say we want to just check if this is working. We're going to do debug.log, and I'm going to name this test, and we're going to make sure we put a semicolon at the end of here. You don't need to put a semicolon here because these brackets almost in a way act as a semicolon because it's specifying a chunk of code. This is an actual line of code where we're doing something, so we need a semicolon there. So basically whenever I press Q, ideally in this console here, it will say test. So let's press Q, and I just don't have it lit up. It said test. We're going to press it again. Test, 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 test. Cool. That's working. So now when we press Q, it says test. We don't want to do this, though. We're wanting to do something else. We want to destroy. We're going to use this destroy function. We're going to say my game object, because that's the game object up here. So if we do that, whenever we press Q, it's going to destroy this cube. Let me actually bring this game object, or the game view, up to here. So we're going to press Q. Whoop. Bam, it's gone into the ether. So that's one example of how to destroy an object in Unity. We're going to talk about instantiating objects later in this class, which is basically a fancy word for spawning something in, which is a lot more fun. But right now, you actually will not need this start function. This is all I want you guys to type up. It's very simple. It's one simple if statement in the void update. This is just to get you comfortable with this. And the reason I'm also doing this is I want you guys to know how to do this early on, how to get the inputs. You could get the input of any key you want here. You could also be getting the inputs of 8 other keys at the same time you're getting. I could create a bunch of these for a bunch of different keys. That's one way you could make a movement script. You could be constantly getting the input of WASD, and then you could be doing different things if you're getting the input of it. So just something to keep in mind. You can also do input.getKey up as well. You can do a lot of different things. So this will only be called if the key has been let go of, basically. And that's what you guys are going to be typing up. And so I will take a screenshot of this after this and post it in there. And that's part of what your assignment is going to be. Now, the fun part. I'm giving you guys a script. And this script, you guys are going to make work. I've coded all of it. You are just going to need to drag the right things in and use it properly in your scene. Now, this is an example level I've set up. You guys will actually be using your levels you have created. This is the doors and keys assignment. This is basically a simple way. When you have this done, I should have made, hold on, let me drag this up here. When you guys have finished this, you'll be able to go over here. Let me just get rid of that. And you'll be able to open this. I'm touching this and I'm pressing E, and this is doing nothing. E is the key I've assigned to open doors when I'm touching them. Now, if we go over here, this is my key, my horrible looking key. When I walk into it, we are going to grab it, and then now, when we press E, it opens the door. Oh, what did I do? And so, basically, by the end of this, you will need at least 3 different sections in your level that you cannot get to unless you have the key. Goodness gracious, I need to work on this FPS controller script. I apologize. That FOV is just... It's horrible. Need to put a cap on it. You can just turn it off, though, if it's bothering you. So now if we press E, bam, this one's gone. Now this one's a bit more fun. If I fall off, I'm just giving up, but it's fine. Woo! All right, bam. We have this key now. Speed running. See if we make this. Okay, well, no one saw anything. Anyway, I swear I made it last night. I made the jump. I swear to guys, I'm not that bad at parkour. I'm actually going to, just while this is under development, I'm going to turn off the FOV because it's honestly making me sick. Where is that? Sprint FOV speed. Just no multiplier. Bad. Okay. We'll keep the bob, I suppose. Okay. So let's actually talk about the script here, which is that I'm giving you, and how this is working. On the player here, we also have this key manager. Now, this key manager, by the way, doesn't have to be on the player to work. Notice how this test object was working just fine with me pressing Q, this test script here, and it wasn't on the player. It doesn't matter where it is as long as it's in your scene. The only time it matters what it's on is if you're getting a direct reference to something on the player by the script being on it. Like, for instance, the rigid body that's on the player, which I am using for the movement. Now, let's go into this key manager script here. We can already see there's some public game objects. Now, first off, what I'm doing here, I could do the exact same thing here within about 1/3 of the code I'm using here. I'm doing it this way, in a simpler way, to show you guys basics and get you used to it. Because there is an easier way to do this. Well, I say easier, a more advanced way to do this with a lot less code that is more efficient. I'm showing you guys how to do it the less efficient way first to get you used to code. Now, this isn't necessarily bad. I mean, it works. It's just not as efficient as it could be. And it's not not efficient, though. I mean, it works fine. So, first off, let's start by going over our variables, which, by the way, if I didn't mention this before, your variables should always be included at the top. Sometimes you will make variables within certain parts of your script here, but in most cases, they'll be up here. So, first off, we have 3 public game objects. This is our red door, our blue door, and our green door. This is getting references to these game objects right here. Now, the next thing we're doing is we've created private booleans. And also, another reason you would name things private is just so when looking at it, you know, okay, I'm not using this boolean anywhere else. I'm using it just in the script. These are private booleans because nothing else is using them. So, the first boolean we've created, and again, you could get rid of all the privates here and this would work completely fine. I just like doing this. So, our first boolean is has red key, and we're setting it equal to false by default. So, this checks if you have the red key. This one checks if you have the blue key. This one checks if you have the green key. Now, the reason we're setting these to false by default is we don't want to start up our game and our code think we have all the keys. Now, if you were saving the player's progress, which is something you get into in Game Design 2, or actually saving data, you would have certain ones of these actually be saved, like that you would not set their values up here. You would set their values in the start function, and then you would get the data that you've stored on the computer of if it's true or false. We're not going over that in this class. It's way too advanced for this class. But I'm just mentioning it. Anyway, these are set to false by default. We have some other booleans here. Touching red door, touching blue door, touching green door, which by default these should equal false, actually. Might as well change that here. I mean, it doesn't really, by default, it'll equal null if you don't assign anything, which is the same as false essentially, so. But it's still good to write it out so you can just visually see what's happening. So, this is basically checking if we're currently touching the red door, because I don't want them to be able to press E and open it from across the map. I want them to be touching the red door. So, the next thing we're doing here, this will be familiar to you. So far, all this should actually look familiar to what we did in here. It's just a lot more of it, right? In our void update, we have these inputs, and we're checking if we're getting these keys. Now, the reason we're doing this 3 different times, and this is again where this isn't as efficient, this is just one way of showing how you can do this, is we're checking here if we're getting the input E, and these double and symbols here is how you check if something else is true within the if statement. What we're saying here and I'm going to type this out just so it looks a bit more obvious. We're checking if you're pressing E and you have the red key and you're touching the red door, then it will destroy the red door. Now, why am I not saying here if this is equal to true? Well, because this is actually, if you get rid of this, if you just put has, like the name of the variable, it automatically says here equal to true. It's automatically checking if this is equal to true. That's why I'm doing that. It's just less that you have to type. Now, you could also do if it's equal to false, right? Or not equal to true. Or you could do this. The exclamation mark is basically a not symbol in C#. So, just an FYI. So we're saying if this is true, and this is true, and this is true, then we're destroying it. Now, you could technically do this all in one if statement. You could do if input get key down E, and then do your other checks within, like other checks within this here. The reason I am doing these separately here is one of two reasons. It's a bit easier to see visually what's happening. Number two, you can actually do debugs here a lot easier. So, for instance, maybe you want text to pop up in front of the player if they don't have the red key and be like, hey, you don't have the red key. What you can do is create what's called an else. Each if statement, right now, if this isn't true, it will just keep going. It'll keep running the code as it goes. It'll check this one. If it's not true, it'll keep going. If you add an else to this and give it brackets, I usually like to keep my brackets like this. It's fine the way it does it by default. Also, it's just easier for you guys to see what's happening. In this else statement here, if this isn't true, instead of running this, it will run whatever is in your else. So what we could do here is we could do debug.log, or again, we'll get into later how you can make text appear on the screen, but you could do something like debug.log and then in here say player does not have the red key, right? And then I put a semicolon. That's just sad. Okay, the semicolon goes here. So basically what would happen is if you went up to the red door and tried pressing E and you didn't have the red key and you weren't touching it properly, or you were touching it but this wasn't true, any of these aren't true, it will say player does not have the red key. Now the problem with this is that, actually, can any of you guys spot the problem here with this, the issue? Yes?
It would have that log no matter what.
Yeah, so basically, yes, exactly. The issue with this is we're checking here, right? If this is true, and this is true, and this is true, do this. If one of these isn't true, or all of them isn't true, two of them aren't true, do this. What that means is that if you're pressing E, even though you're not next to the door, it'll still say, player does not have the red key. We don't want that. So what you would actually do is you would do a check within here and say, hey, do they have the red key and are they touching the door within here, and then do the debug right there. Or you would just do it for the red key actually and then do the door. Again, I'm doing it this way to just make it easier for you guys to see for those of you who are not familiar with programming. So we're doing the exact same thing on all these. We're checking E, E, E. We're checking has the red key, has the blue key, has the green key, touching the red door, touching the blue door, touching the green door. If these are both true for each of these, it destroys its corresponding door. So, how do we actually change these values, though, based on if we've collected the key or not, or if we're touching the door, right? And that is when we're going to get into collision detection and trigger detection. This is very important. This is something that you will use a lot in game design. This on trigger enter and on collision enter are super, super, super important. So, first off, what is this? What is it doing? This is actually its own function. I'm actually going to close this so that way it's a bit smaller here. So let me close this too. I just want to make this as condensed as possible. So we have this void on trigger enter, right? This is separate from the update. This is its own thing. Just like the update, this is also is constantly checking, right? Now, what is it checking for though? It's checking if you're entering another collider. So if you're colliding with another object. Although, not exactly though. That's what this is. On trigger enter is a bit different. And this is when we need to talk about different types of colliders. So, any second now, come on. Okay, if we go to this door here, we go in here, you'll see it has a box collider, right? So this is what allows us to collide with it. In here, you'll see this is trigger option. Let's just turn this on and see what happens, first off. We walk right through it. There's actually no collision there anymore because it's a trigger collider, which is weird, right? It's a collider. Why are we just walking through it? Well, triggers specifically are for these functions in Unity scripting. What a trigger collider does, if we click, let me turn this off. If we click this here, the keys are set to isTrigger. I've set this up because I don't want to collide with the keys. I want to be able to walk into them and collect to them, right? So if basically what you're doing here when you set this to an isTrigger is you're allowing the player to walk in the collider. Why would you do this? Well, that's what the onTriggerEnter is for. This checks if you are within a specified collider. OnCollisionEnter detects if you have collided with another collider. So we could just use both of these here, or we could use one of them. We could just use OnCollisionEnter for the key as well. I'm just doing this to show you the different ways. We would want to use OnCollisionEnter here because we want to still be able to collide with this when we don't have the key yet, right? It wouldn't make sense to use a trigger here because then you could just walk through it. Now, maybe what you would do is you could create an empty game object and put a trigger collider on it and make it the red door zone, right? So if they walk within that collider, then the door opens, or they can press E and the door opens, or it will pop up, hey, press E to open the door, which is how you do that type of stuff in Unity, or one of the ways you can. But that's the difference between the two. OnCollisionEnter detects if you've collided with the object. OnTriggerEnter detects if you are currently within that collider. So that's what we're doing for the keys. We're using OnTriggerEnters. So we're saying void OnTriggerEnter, that's the name of the function. And now in here, this is a bit tricky, right? This is new. For a lot of people, this is going to be a little complicated. When we see this collider other in here, when you create a function, because that's basically what this is a Unity function. You can create your own functions too, but you can have parameters in your function or accept certain parameters. This specific function accepts a collider parameter. What we're doing here is we're creating technically a collider variable called other. This is holding, again, a variable's container of information. This is holding the collider data of the specific object that you have, the collider that you have entered. That's what this is basically. So when you say collider here and name it whatever you want, I've named it other, as in like other collider, it's storing the other collider. Now, this is great because we can use this other here. So, or I said stores other collider. It technically is the other collider, but also the other game object, really. So in here, this is basically a comment of code, by the way. When you see this // anything after it is just for you to see the code, for you as the programmer to see. This doesn't actually do anything in your code. So we have some if statements here, and actually some else ifs, so we can talk about that. And in this first if statement here, we're checking if the other collider that we've entered has the tag red key. This compare tag is another Unity function for checking the tags of a specific game object. How do you tag an object in Unity? Well, if you click on an object, you'll see it has a tag and a layer. If we click on this tag option right here, you'll see we have add tag here. And I have already added all these tags. You will need to add these tags yourself. If we add a tag here, click add tag, we'll go over and we'll see all the tags we have, and we can click plus, we can add our own tag. We're going to call this test and save it. Now this didn't automatically apply it to the object. We still would have to go back and tag this test or whatever we want. We're going to leave this untagged though. What this allows you to do is check if you're touching a certain object based off of its tag. So if we say compare tag red key, we're checking if the object we're currently colliding with is tagged red key. So if we collide with this right here, it's going to check, hey, is this object tagged red key? If it is, we're going to execute this code here. And what this does here is it says has red key equal to true and destroys the other.game object. What is the other game object? Well, it's our red key. That's the one we're touching, right? So what this does is it effectively gives you the red key, right? We're setting this variable to true, that we have it, and destroying the object in our scene, so we can't run this again. Now, these else ifs is kind of like an else statement, but not exactly. An else statement's a bit different. An else statement is just the opposite of this. Else ifs are like, okay, if not this, maybe also this, right? So we're putting another check within this. You could also just do completely separate if statements. Either one works. So in this else if statement here, we're doing the same thing. We're checking, hey, if it's not the red key, is it the blue key? No? Okay. Is it the green key? No? Oh, okay, whatever. And then it doesn't do anything. So we're checking, is it this one? Is it this one? Or is it this one? So maybe it goes, nope, that's not the red key. Oh, it's the blue key, though. Let's do this. Or maybe it's, oh, it's the red key. Let's do this. Don't do these two, right? Or maybe it's, no, it's not the red key. Skip over that. No, it's not the blue key. Skip over that. Oh, but it is the green key. Let's do this. That's basically how that works, right? And then we're destroying each corresponding object and setting each corresponding Boolean value to equal true, right? So this is one piece of the puzzle. This is how the key collisions in key logic works. Does this make sense? Does anyone have any questions, or is anyone confused? Okay, cool. I know this is a lot of information, and I'm actually going to have us take a little bit of a break, and then we're going to go over how the collisions with the doors work, how the on-collision enters and on-collision exits work, which are a little bit different but do similar things. So I'm going to take be back at 9:15, or you can stay in here and just chill and we can chat. Either way. I know it is a handful of information.
So I've had so many problems this week. Aside from being sick for the whole week.
I had COVID, so I understand.
Luckily, I just had a cold. It just was
Good.
a nasty cold.
When did you say to be back by?
9:15.
What time is it?
9:07.
Thank you.
Yeah.
But I think my biggest problem is I think I made everything too large a scale.
Well, so here's the good thing about that. If it's too large, do you mean like the player's like really tiny compared to it?
Well, I resized the player, but my issue is I tried to resize everything and the textures won't resize. The texture, no matter how small I make it, the textures stay the same scale to the objects. Even if I replicate or I tried just completely copying and pasting it.
So let me show me an example. Show me like one of the textures that's doing what you want it to do.
Hoping the player's heart. I have like 5 different constructs that I just keep making new iterations. So this is the one that I really like so far. Just the textures.
I'm being goofy.
Yeah.
We can fix that.
Okay. Yeah, I wrote down a couple things that I was having issues with. I also
takes its sweet time.
well, I do have a lot of stuff.
Yeah.
I also did think about maybe I shouldn't have made everything one object, because now it's
Well, so if you remember, there is a way to split things up, and I can show you again if you want. Which will make it easier. With Pro Builder, you can select certain things and split them up. Okay, yes, this is a tiling issue. I know how to fix this.
okay.
So that's the good news. I got you. Don't worry.
Okay.
We're good. We can fix this very easily. Actually, you're gonna be very happy.
Good, because I was like, not.
So yeah, you will need to split things up if you want your walls textured different and like stairs textured different, but it's not too hard to do. If anything, it's just tedious, you know.
Yeah. Which that's straightforward.
So here's how we fix this. So let's see. Can you just get me to your material that you're using actually for that floor? There.
I think I was using this one.
Okay, so here's how you're gonna fix this, basically.
And if not, that's the one I want to use.
I'm gonna put this light on in your scene, or turn off the. This is basically turning on and off real-time lighting. If I turn it off, it just basically lights up everything, so you can see this a bit better. So okay, well I don't need to go through it. So we can see this is repeating a lot more than we'd like it to. What you can do is change the tiling of your texture right here.
Okay.
So, okay, this is not the one I think because it would
we would have seen it updated here. So this is actually here. Hold up. Desert Cliff underscore rock. Is it this one?
Yeah.
Holy moly. Okay.
Yeah.
Sorry.
I know that's, I assuming that was my issue.
Desert Cliff underscore Desert Cliff rock underscore. VWM shader. It is, of course. Okay. This is.
Can we just swap it with the other one?
Yep. So, we swapped it now. You should be able to, yes.
Oh, okay.
So, you can change your tiling here. So, put this at like that, and then sort of put one here. See, that already makes this look way bigger. You could even go, you could go even bigger than this by decreasing the number even more. There is going to be repeating. That's just kind of how it is. It looks like it didn't get assigned to this one. Keep in mind, if you want it repeating differently, you'll have to make a copy of this and use it differently. I am curious how it would lay on. That's actually not too bad. So you could decrease the tiling even more. That is how you'll fix that, is go into the texture here and change the tiling. So you can even make this like 0.5, 0.5. And if that's still too big, you can make it, or if still too small, you can make it even bigger just by decreasing that number. So yeah.
Yeah, okay, thank you.
Negatives, or like you could also do.
These are, I didn't think about it when I was making it, but this is scaled to like thousands of meters.
So this is a little better, for instance, and you can keep messing with that too. But that is how you can fix that issue. Just change the tiling of each material individually that you're using, and that should help with that. Thanks. Yeah, no problem. I know it's. Yes.
So, I have a lot of background in C++.
Okay.
I.
C# easier, so.
Okay, that's kind of what it seems like. It looks, because like I was like, man, there's no call function for
I know.
void.
Yeah. Nope. Easier, less control, but
so
easier.
If I like, because the way that I do it instead of looking things up is I get a book and I like sticky tab through a book. Do you have any recommendations for like, should I'm sure you don't have recommendations, but should I get a specific C# and Unity book?
I personally have never used a book. I've always learned online, but I'm sure there are ones out there.
Or like, would you recommend that I just got like a C# book and then like?
Honestly, here's the thing. You have C++ background. The syntax, it's something you'll get used to. I would recommend a C# Unity book.
Okay.
You can also, Unity does have decent documentation. So hold on, Unity C# documentation. So I'll put a link to this, but Unity's documentation is quite extensive actually on a lot of different types of stuff. So that's just one resource you can use for getting information. Luckily, Unity's documentation is so nice you can actually look up most issues. So like for instance, searching the hierarchy for a game object, how to search the hierarchy. Do I remember how to spell hierarchy? Hierarchy, that's not how you spell it. Hold on. Hierarchy in Unity for a game object. And usually you'll get an answer pretty quickly. Yeah, bam, we already have one right here. Full on documentation on exactly what you need to do. So, it's quite easy to find stuff, is the good news with that. And Unity's documentation is quite extensive for that. I guess, is everyone back? Are we missing anyone? I guess we can just get started. It's 1 minute prior, but okay, so the last thing we need to go over here, we now can collide with our keys and set those booleans to true. Like we have the red key, we have the blue key, or we have the green key, right? Now, how do we do the doors, right? How do we know if we're touching a door currently? So this works a little bit differently. So first off, we're using an on collision enter. basically does the exact same thing as an on trigger enter. The difference here is that it's a collision. It's not a trigger. It's not if you're entering the collider, it's if you're touching it, basically. So we're going to say, let's see, is the other game object we're touching, is it tagged red door? If it is, set touching red door equal to true. If it's the blue door, set this to true. If it's the green, set this to true. If it's none, don't do anything, yada yada. Basically, what you saw already. Now, here's the thing. This is for entering it. We want to set it to true. We want to set them to false when we exit it. So we're using an on collision exit. There's also an on trigger exit as well. So when we exit, if we exit a collider tagged red door, it will set touching red door back equal to false. And then the same for all the other ones. So for instance, if we walk into the red door, it's going to set touching red door equal to true. As soon as our collider leaves the red door's collider, we're going to set touching red door equal to false. Now, the reason this script actually needs to be on the player is we're checking if the player is colliding with these things, right? And that's the important thing. So now we're able to know if we're touching a specific door and if we have a specific key. Now we can come back up and do these checks here. Are we pressing E? Do we have the red key? Are we touching the red door? If we do, destroy the red door. Now, when you're setting your game objects up in your scene and setting the script up, what you're going to have to do first is you're going to have to drag the script on the player rigid. The script I'm giving you, this key manager, right? You're going to have to drag it onto the player rigid, and you will need to assign the red door, the blue door, and the green door, because that's what we're destroying in here. We're getting references to those game objects so we can destroy them. So you'll simply find the game object that your door is, drag it in, or it could be a barrier, like rocks and stuff. And right now we're just destroying them. Later on we might get into animating them, like calling on an animation instead. Right now we're destroying them for simplicity's sake. So that's something you will have to do. The next thing you will have to do is make sure that whatever you tag this here, you can tag it something different if you want. You just have to make sure that you change what it's tagged in the script here. This has to match the tag on it. I would recommend just tagging it what the names are in the script. So you'll need to make sure this is tagged red door. Now, that being said, you do not have to use a color-coded system in your project. And if you don't, it doesn't really make sense to use red door and stuff. So you can go in here and change this to maybe key 1, key 2, key 3, door 1, door 2, door 3. You know what I mean? You do not have to use a colored system. This is simply to make it easier for you guys to understand. So, red door, blue door, green door. Or door 1, door 2, door 3. You have to make sure they're tagged properly. You also need to make sure that your keys are tagged properly. Red key or key 1, blue key or key 2, green key or key 3. In addition, the doors will need to have colliders on them, and they need to not be set to trigger. You have to be able to collide with these. The keys need a collider on them, but they need to be set to trigger. And one thing you could even do if you wanted to is, hold on, you could make this collider bigger. If you want the zone to be bigger for the player to walk into to collect the key, you can absolutely do that. It can be bigger than the object. That's fine. Any second now. Any second now. There we go. So you'll see we collected a bit sooner. That's fine. But make sure that you have those things and that you're tagging things properly. So this is a very viable method for how to do this. And you can use tags for a lot of things. And layers work a similar way, but we're not using them for this specifically. In this case, it's probably a bit easier to use tags. So in your level, you're going to need at least 3 different keys, 3 different areas that you need a key to unlock. Now, one limitation of this script, and this is not something I'm going to show you guys in this class, this is a Game Design 2 thing that goes along with different type of interactable. If you guys want to do this yourself, if you have prior programming experiences, you can. One problem is, wait, is this a problem? Let me just see. Maybe it isn't a problem, actually, with how this is set up. I'm trying to think. It's easier if I just test it, I guess. Maybe it is just fine. Because it should just set these to true. And then bonk. Bonk. But I shouldn't be able to get through this still. Well, it helps if I make the jump. Okay, you know what? Hold on. Let me just... Because apparently I suck at this. I swear I made the jump last night. Don't make fun of me. Bam, bam. 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 Awesome. So, never mind. There is no issue with that. If you have your keys before the door... Oh, I know what I'm thinking of. I'm thinking of... There is a script in Game Design 2, a more advanced one, where you have to be careful about that, but you can fix it. Never mind. I'm thinking of something completely different. Don't worry about it. Put your keys wherever the hell you want them to, and put your doors wherever the hell you want them to. So, yeah, so you're going to need at least 3 different areas that have to be accessed. Maybe it's rubble that clears or something like that. You know, it doesn't necessarily have to be a key, right? But 3 different quote-unquote keys that go to 3 different quote-unquote doors to get to different areas of your levels, basically, using this script that I'm giving you. This is to get you used to setting things up in your scene and being able to work with tags and game objects and references. Now, in addition to submitting that, you're going to submit like a video walkthrough of that with your player controller. In addition to that, you also will just need you could create a different project for this if you wanted to, because it's quite simple. You don't even need the player controller for this. You can just set your camera up. I would like you guys to type this out yourself. Again, I'm giving you this key manager script here, but I'd like you guys to set this up yourself. I'm also going to include this entire project, so if you really get stuck and you need to, you can look at this project as a reference and download it and just see what's up. Now, one thing, there's going to be people that have questions and have issues with this most likely. Things to check before you email me. Are all of your objects tagged correctly? Are the colliders set up? Can the player collide with them? Do the names match? Just some things to think about. So, yeah. So I'm going to go ahead, and I already have this scene ready for you guys. I am going to go ahead and take a screenshot of this script for you. And if you have trouble getting your Visual Studio Code or Visual Studio Community set up and linked to Unity, just email me and I will help you with that. It's a little weird, especially if you haven't done it before. Where is my snip? Excuse me. Okay, I guess I won't use the fast key because it hates me. Bonk. Save. Just save it to the desktop. I don't really care. Simple script. Bonk. There we go. And then what I'm also going to do for you guys is I'm going to export this key manager script here. So this is just the same as exporting a package actually. I'm going to export package, and I don't want the example script. I don't want the player. I just want the key manager. Okay, well, you don't have to be mean to me. Key manager. There we go. We're going to export this as its own Unity package, and this will be the key manager script. Beautiful. So now that I have all of that, I'm going to show you exactly where I'm putting it in the assignment. So we have our simple script here. This is the actual full-on project if you want it. And then our script here for you guys to use. So you would download, just works the same as any other package. Bring this package into your Unity project, and it's just a script, and then you'll drag it onto your player, and you'll be making and setting up everything in your scene. So let me go into no, yes. So first off, what is this? Hold on. This is from a past. Okay, we're just going to get rid of that entire thing. What in God's name is this? Okay, just no. We'll type that up. Type that up soon. Anyway, so in here we are going to put the lecture. Let's actually grab this. We're going to put the lecture in here, and it will be under this. Then we are also going to put resources. Under resources, this is where all your stuff is going to be. So, first thing I'm going to put here is a file. He's looking for the file. He's just going to drag it in. Okay. First off, we have our key manager script. Next, we're going to have our, let's drag in this entire project here, which is going to take a second. Oh, wow, that went faster than I thought. The beauty of zip files, and then the script example image. And then in here, I'm going to type up everything I just told you that you will need also in the requirements. So I'm going to do a requirements section here. I thought this was all set up already, but I don't know what this is. Requirements. I can't spell today. Okay. Beautiful. And I'll get a rubric going. You will create an ArtStation link with the video of you walking through your scene and a video of you going over the script and showing that you got it to work and typed it up. I also want you in your videos to just go into your scripts real quickly and just show that you have that script in your scene too. Again, things I will put in the requirements and in the rubric. But right now, while I'm doing that, I would recommend you guys, if you can, if you have your project, to work on it here in class, so that way when people inevitably have issues, they can just ask me right here. So, but yeah, that's the first programming lecture. How's everyone feel? I know it's kind of a mouthful. Good? Cool. Awesome. So, in the future as well, just kind of, again, I know I've been over this, but next week, we're going over timers and resetting the player. Timers are something that's very important in Unity. This is how you make things like, well, a lot of things work. FPS controllers, guns. I mean, timers are super. It's how basically to create your own timers and ticks. You can keep track of the game time, things like that. Human collector. I hate this. I hate the name of this assignment. I did not make that name. Anyway, I believe that's instantiating objects in. Then we're going to go over, we're going to take a step back from programming for a bit, go over terrain sculpting and design in Unity. Then we're going to get into sound design, a little bit of enemy AI, which is going to be pretty fun. We're going to get into menus and how to script menus and UI and stuff, which is actually really easy in Unity. And then that's when this class will end. It'll be your final project, accumulating everything you've learned. Game Design 2 is going to be a lot more programming heavy, which I will be teaching. And you can expect in that one, you will still be given scripts. It will just be a bit harder to implement, and you'll be expected to do things yourself as well and create things yourself. And again, I really want you guys to watch this video here. Again, these, it's fine if you don't watch these. I didn't even put these ones in here. These are already in here. I did put this one in there, though. This is a really helpful video, and will give you a little bit of a head start in things. It talks about some of the things I talked about and goes a little further as well and talks about some things we're going to talk about later in this class. But it sums things up very well. So I really recommend you guys check out this video here because it is super useful. And honestly, too, if you have time, just screw around. I mean, I got good at what I do because I messed around with shit. So it helps. It really does. But yeah, you guys can go ahead and get started. I'm going to type up the requirements and rubric, but I thought the last teacher did that for this. Apparently not. Okay. Because this is the same assignment we've had. Don't know why it's not there.
So for the outdoor assignment part, you were talking about terrain.
Yes.
I know the terrain function doesn't work. The last level design class I tried to do, I tried to build an indoor level, like a cave system with the terrain.
Yes.
And that was a nightmare.
The terrain does not really work well when it comes to indoor, caves and stuff. I've made cave levels in Unity before. The best way to do that is either it can be your own models or someone else's, but get a bunch of rocks and stuff, and what you do is you build them up and create prefabs of cave wall chunks, right? And then you put them together and stitch them. That's how I've done that before. That's what I did for the horror game I made a while back over winter break, and then I did that too for our capstone. I had to end up making a cave level, which I should not have had to make because the level designer did not do it. And then I did the same thing there. But yeah, no, the Unity terrain tool, that is one of its downsides, is it struggles with that. It struggles with like basically indenting like in caves. I swear, Planet Coaster does that better. Anyway, but yeah.
I have my project on the computer in the lab over there, so I have
Yeah,
to
that's fine.
transfer it. Do we just grab the whole file?
Honestly, if you want, you can work on it in there. If you
I
can't,
need your help so bad.
Okay.
I'm so stuck.
okay, that's fine. Then
Yeah.
bring it. Yeah. So you have your entire project there.
Mhm.
So I would just grab the entire Unity scene, like I've shown you before. If you need help with that, I can.
I think it's just
and
that
zip it
I
up.
didn't grab the. Yeah, I didn't grab the folder.
Okay.
That is
So
it.
grab the whole thing. I would zip it up too. It'll in the end it'll make things faster.
Okay.
It might take some time to zip it, and unzip it, but it'll probably be faster than transferring it without zipping it. From
Mine took like 15 minutes to zip, and it's like 47,000 files.
I
So,
also need to
should be.
get some meds, so I will be right back.
Understandable. Let's see. Quinn and Griffin still aren't here. This is why I record my lectures. I'm gonna stop.